Welcome to December 8th LeetCode Challenge. Construct string from binary tree. Given the root of a binary tree, construct a string consisting of parentheses and integers from a binary tree in pre-order traversal way and return it. Omit all empty parentheses pairs that don't affect the one-to-one mapping relationship between the string and the original binary tree. So give an example 1 here. We have the binary tree called root, and we're giving it a binary tree consisting of 1, 2, 3, and 4. And we basically will want to return the string representation using parentheses of the one-to-one mapping of this binary tree. So basically what you get is each nested level of parentheses, you'll get another lower another child parent binary tree relationship. So for the example of a binary tree as such, you get the following. You get the first value being 1, and then you open up parentheses, you get 2 and 3 here. However, 3 you get 2 actually, and then you get 3 on the outside here, and then within 2 you get another leaf right here, which is 4, and that's kind of the gist of that. Originally it needs to be basically has empty, so it's probably best to kind of so we omit any empty parentheses essentially. To kind of do this in a full manner here, if we go 2 here, and then we have also 3 as well, and then within 2 we also have 4, and then an empty, and that is encapsulated inside 2 as such, and then we have 3, and that's going to be encapsulated alone, and then 3 has basically no leaf nodes. It is a leaf node itself, so therefore remove all empty, and then remove empty here, and then you basically get no spaces, of course, the following, which is our solution. Given this binary tree here, example number 2, we have basically the root tree called 1, 2, 3, null, 4, and this time we do include basically the empty parentheses because we do pass it null, and that is a valid one-to-one mapping. So we cannot omit it, and essentially that's it. The constraints of the number of the nodes of the tree ranges between 1 to 10 to the 4, and the value of each node is between -1,000 to 1,000. How do you go about solving this? So if you want to go about making strings, I would say the intuition would be to solve this using a preorder traversal of binary tree, as mentioned here. Constructing the string representation while omitting unnecessary empty parentheses without violating the one-to-one mapping. The first thing we should do is the tree takes should take in a tree node as the root as its input. So the first thing we should do is check if root is null. If so, return the empty string, and that could be our base case. If root equals null, return an empty string. That's the base case out of the way. The next thing we should do is initialize a string builder, but so basically we have to build a string and append it to the current value of the node to a string builder. Let's go do that right now. So define string builder called SB, new string builder, initialize. We want to append the root value to the string builder, and we could do string builder.append, and we're going to append the root value as done. So that's the first value here. Our next thing we should do is if we check the left and right roots, if the root dot left, so remember doing this in a preorder traversal manner, is not equal to null, or root dot right is not equal to null, then we want to append to string builder the following. We want to append the first, want to append the parentheses, opening parentheses, and we want to append the recursion of the following. So we want to call, so you want basically to take the root dot left and pass it through tree to string function again. So it's a recursive call in order to get the root value of that specific left node or left root dot left. So we do a recursive call here to string, and we pass it the parameter root dot left, and then we want to append the closing parentheses as such. Else, no, not else, if root dot right is not equal to null, then we want to append the similar idea, the beginning of the parentheses, and we also want to pass it root dot right. So because append dot tree to string, pass it root dot right. The reason why we checked if left or right is equal to null is because we wanted that one-to-one pairing mapping. And we have basically append the closing parentheses here as well. And we recursively called all of that. And by the end of this, we should be able to return our string builder. And we should call toString to it as a string to return. Let's take this for a ride. All right, looks good. Yep. Oh, did this before in Python. So there you go. We effectively created a string builder to append the preorder traversal of a binary tree. Let's see if we could do some complexity analysis on this. Time complexity wise, we have big O of n, where n is the number of nodes of the binary tree. The algorithm visits each node exactly once during a traversal and constructing the string representation of that. And the string build operation is constant time. So overall, time complexity is big O of n. Space complexity for memory would be big O of n as well, because we do the recursive call here, building the stack space. And the string builder stores the string representation of the tree, which could also take up big O of n space if the tree is skewed, meaning that there's only like if the tree has one main branch only and nothing else, the rest is null. And or it could be big O of log n if for best case scenario where the tree's balance has balanced depth. So each tree has a equal amount of symmetry in terms of the leaf nodes. But yeah, that is it. Have a great day, everyone.